Hey, let's do a fun LeetCode problem. Um, this is kind of a warm-up one, and it's a classic problem. You'll see it a lot on interviews. It's called Two Sum. Um, and you might be familiar with it, but let's go through the requirements real quick. Okay, so given an array of integers, nums, and an integer target, return the indices, that's important, of the two numbers that such that they add up to the target. So nums is going to look like this for one test, and then you're going to have a target equals 9. And so basically the algorithm, you through the array, and you look at a naive solution, we'll look at each value of num at each index and say, does it add up to the target? So you'd start at 2, and you would be doing a nested loop where you'd say, okay, so 4 in nums, 2, and then go to the second index, 7, and that adds up to 9, so you found your solution. But to fulfill all the test cases with a naive solution, you would need to potentially, in the worst case, do n squared time complexity, searching through at each index, search then through every other index in the array, which is inefficient. The efficient way to solve this is to use a hash map, and in JavaScript we can just use an object because an object uses a hash map under the hood. So I'll create my variable object and instantiate it to a JavaScript object, and then I'll simply use the for each method on the array, use an arrow function, and I'll call the number num and then the index index. And what I want to do in this object is I want to build a object that contains the index that looks like this, that has the index and then the num. And the reason I want to do that, I'm sorry, it's the other way around. It has the num and the index, which is a little bit inverted. The reason I want to do that is I want to be able to then go through the array a second time, and I want to see when I subtract the target, then do I have that value in the object? So that allows us to have direct time lookup, which is great, which is a big improvement over having a nested loop that would be O of n squared. So let's finish implementing that. So object, and then again, I'm going to set the index equal to num there. And yeah, so let's go and then let's create our second loop. So the second loop is going to be, here we're going to use a for loop because I want to be able to return. But if you return inside for each, it's just returning from the arrow function, but that won't return out of the outer function. So I'll say let I equals 0 and I is less than nums.length, and then I increment it, and then so again, so I'm gonna create a constant called comparison. And here, now I'm going to do, looking into my object, do the comparison that I was talking about. So what I want to look for is nums I minus target. I'm sorry, I think I have it the other way around. I think it's target, and I'll be able to test this by running the test cases, but I think you want to do target. So in this case, it's 9. I want to say target minus, for example, 2, is that found in the array? And then that would give you 7, and that's the right answer for the indexes shown in the output here. So that's the comparison that we want to look for in our object. So once we've built that comparison, we can reuse it a couple of times in the following code. So I want to say if object comparison then return the array that the output is expecting, which is an array of indices. So the first, and it's supposed to be allowing it to be unordered. So one of the indices is going to be that object comparison if it's found, and then the other index is going to be I, because we're going through the array, and that's the index that we're on. And actually I'm going to put them in the other order because in these examples that's the order that's used, and that might be easier to see. Okay, so now we're returning that, but this is incomplete because, for one, there's a couple of additional checks we need to do to make this work. One is that you can see the value of the comparison index when looked up at the object could be 0. So we don't want to be getting have bugs based on truthiness, because that would be falsy, and then that would fail even though it was found. So we want to say, is that undefined? That'll guard us against this case where we have the one that we're looking at is, for the comparison, is index 0. And I guess that wouldn't be true here, but it could be true in other test cases. But we also want to check that the number we're looking at isn't the same. So we want to do object comparison, and make sure, again, these are indexes. We want to make sure that this is not equal to I, because we might find that we're pointing back to the same index. So let's see what errors we get. Okay, so we're getting lots of errors. So here we're getting strange results where it's the output is 1 and 11, which is strange. So that's clearly we're not putting in the index. We're also not putting in the right value that's supposed to be found. So yeah, so this isn't right. So what we want to be returning is the that is object index. Oh, right. So this is going to be I did this in reverse accidentally. We want to have the indices be the values, but then it's confusing. The index is going to be what's going to be the value of the object. It's definitely a little confusing. Okay, so now we're passing these test cases, which makes sense. So that was the bug. Make sure that when you solve it with this, if you're using an object, that you set the object indexes, the properties, equal to the actual values in the array, but then the value is going to be indexed, so it's like inverted. And I think the other comparisons are accurate. So let's try submitting it. Let's see if we have any other failures in test cases. Nope, looks like we're good. All right, and let's use the time complexity analysis on LeetCode to see what we come up with. So it's giving us O of n, and that's what we expected. That seems to be accurate. You can see that there must be some other more efficient algorithms out there, but it's hard to beat O of n. I don't, yeah. Anyway. Oh, I guess that maybe you could do this in direct time. So let's just for fun, let's see if we can find a direct time solution, which I'm going to ask AI for. Because I think it's O of n, because we do iterate through to create this object in JavaScript, but whether we create this or use a map, I think it's still going to be requiring us to go through the array to create this object, so we can then do the rest of it in direct time lookup. Let's see what AI says. And I'm sure it's going to say that there is a direct time lookup, and we'll see if LeetCode agrees with that. So is there constant time? I feel like for two sum there is a constant time solution. Okay. This says there is not. All right, but it pointed out that yes, you can, and this is a tricky point. I think that you probably won't get dinged for this during an interview, but it would be great to know it. They are asking you, or this it's indicating that you don't need to have built the object beforehand, but I've definitely seen solutions where this is a common thing to do. But you can, as you're going through, go ahead and build the object as you're building it. I'm a little suspicious of that, not gonna lie, because I'm imagining that maybe you could find a test case where that would fail. And let me ask AI this. Could there be building the object as you iterate once would fail? Could there be a building the object as you iterate once would fail? Yeah, essentially this is saying that it's going to be we're still going to be checking each case, so we can build the array. So let's make that improvement, and then we'll pass our interview with flying colors, because after building this solution, we'll say, oh, here's an improvement that we can make. We'll say, yeah. Now we're no longer in the for loop, so I need to change this to object nums I equals I. And that should give us the same. All right. Let's see how much more efficient it is according to LeetCode. It says that we're super efficient now. I can't analyze it anymore. All right. Well, thanks for doing two sum and going through how I like to solve problems. Yeah, have a great day.